We'll look at a problem where a vessel goes aground and then has to be refloated. And we're told the port is Ullapool and the time that we run aground. And it tells us that we have to have a 0.5 of a metre extra to break from the mud. In other words, a height of 0.5 more. The first thing we have to do is find out the height of tide that we went aground. So we'd go into the tide tables on the day and we'd look at the tide. Obviously it's an ebb tide going from high to low, and it's at 10:30, and then we put the low high water values on, go to 10:30, come across, and we can read that there was 2.1 metres of water when the vessel went aground. And remember, you have to get the daily range between 4.6 and 1.4, 3.2, and visually interpolate, as I've done here, to accurately find the correct position to read off the height. So we found there was 2.1 metres. Therefore, we need 2.6 and the time at which we can break free. So we then go to the subsequent flood tide from low to high. So now it's important that we use the left hand side. So the high is at 1818. We come down with the 2.6, interpolate and read, by my estimation 1438, there would be sufficient water to break free. So notice with this type of problem, first of all you plot on the right hand side because it's a falling tide from high to low, and then the subsequent tide will be plotted on the left hand side because it's going from low to high. A common mistake students make, I don't know why, is to use this side for both, but you've got to be clear that these graphs were going low, high, low. In other words, the left side is a flood tide and the right side is an ebb tide.